Okay, we're back. I've got a little bit of time before kids start coming into class, so we're going to get one more video up, and it is the standard deviation is what we're talking about right now. Okay, so this whole setup here is really designed to get one last answer, which is the standard deviation. And if you mess any part of it up, then your standard deviation is going to be messed up. But it builds on itself, and we start pretty simply. So hopefully you can kind of see where we're going with it in the end. Okay, so our data points, our data is X, and it's this data up here, okay? And I like writing it in order. You don't have to write it in order to get this problem right. I like writing it in order because it starts showing some interesting things of what's happening as you go through the process. You start seeing like, oh, that's what they're talking about, okay? So I'm gonna start with 61, okay? And then 74, okay, and then we've got 80, we've got 83, and then 92. Okay, so we're just, this little sign right here, this little symbol, the X with the line over it, that's just the mean, okay? So the mean is you add everything up and divide by the number of data points. So in this case, we're gonna go 61 plus 74 plus 80 plus 83 plus 92, okay? And we've got 390, okay? And then our n is the number of data points, okay? So n is number of data points, okay? And number of data points, well, that's 1, 2, 3, 4, 5 data points, so we've got 5. So we're going to say 390. We got our 390 already in the calculator. So 390 divided by 5, and that is 78. Okay? Okay, so if we look up here, we know that the x is our data point. So we're just going to bring x over 61 minus our mean, which is 78. Okay, so we got 78. And so 61 minus 78, we're going to get a negative number. It equals negative 17. Okay, our next one, we've got 74 minus 78, and that is 4. Okay, and then we have 80 minus 78 equals 2. And then we've got 83 minus 78 equals 5. And then 92 minus 78. And that is 14, I believe. I'm just going to double check that, make sure I'm not crazy. It is early in the morning for me. It is 14. Okay, so we've got all of our next step of the standard deviation. We've just taken the data point and subtracted the mean from it. Okay, so after that, we square our data points. So 17 times 17. So it's really just saying what we did here squared. So we're doing 17 times 17, and that is 289. 4 times 4, that's, I can do that in my head. I got that one, 16. 2 times 2 is 4. 5 times 5 is 25. And then our last one, 14 times 14. I think I know what it is, but I just don't want to make a mistake. So 196, okay? All right, so at this point, it says sum. Sum means adding it up. We're kind of doing the same thing we did over here. We're doing it here, but we're just adding them up. The squared deviations, okay? So we've got 289 plus 16 plus 25 plus 196, and we've got 526, okay? And then the mean of the squared deviation, well, the mean, so we're taking the average of the deviation, so 526 divided by 5, that gives us 105.2. And then our standard deviation, you take the square root of 105.2, and since I already got it on my calculator, I just hit the square root button, and that gives it 10 point, and we're gonna go to the thousandths, so 10.256 7. So we look at the fourth one and it's larger than 5, so we come back to this guy and make it a 7. So 2, 5, 7. Okay? All right, so there's your standard deviation. All right, use the data to make a dot plot. I use X's instead of dots, but if you love dots and like you hate X's, then use your dots. I'm gonna go ahead and use X's just for our purposes. Okay, so start off with 22. I go find 22 on here, and it looks like, what are we counting by? It says 1, 2, 3, 4, 5. So we're counting by ones. So here's 22. So 21, 22. I'm gonna put an X. I'm gonna cross it out. And then I go to 24, which is right there. Put an X. Cross it out. Go back to 22, I put another X. So I've got 2 data points of 22, so they're just getting stacked on top of each other. 17 is my next one, so 16, 17. And then I've got 18, so 15, 16, 17, 18. And then I gotta go to 16. Oh, 24, there's another 24. Another 22. And then I've got 2 21s. And that's it. Done with that one. Okay. So the table below shows the results of calculating the mean, median, and IQR and standard deviation of 2 algebra classes test scores. Compare the measures of centers for the 2 classes. So if we're talking about measures of center, okay, we're talking about the mean and the median. Okay, the IQR and standard deviation is talking about the spread. Okay, and this is the center. Okay, so if we're comparing the measures of center, we can include the spread in when we're talking about the measures of center. Okay, so let's focus on the mean here real quick. So the mean of each class is about a C, right? The first period did a little bit better than second period. Okay, so first period we have you could say the mean is higher. Okay, higher. But the median is lower, showing that the data is more spread out for first period. Okay. So the data is also,
Good morning, Viking children, students.
I do work at a high school, so
everyone else in the world. Today is a 1, 3, 5,
So
7 day. Then
here is Mr.
second
D.
period final. Then 4, 6, 8. 1, 3, 5.
We'll wait for
7,
Mr. D to finish.
Then lunch. Then your second
Thank
period
you,
final,
Mr. D.
2, 4, 6, 8. Have a lovely day.
Okay, so first period and first period's IQR and standard, I'm going to just call it standard deviation, SD, is larger. So their students either did really well or not so well. Second period scores, they got a lower mean, but their standard deviation is lower and their IQR is lower as well. And their median is actually higher, showing that students overall in second period did better than first period, even though their mean was higher, even though first period's mean was higher. So anyway, I'm going to be pretty flexible on this answer. You just have to comment on how like the mean and the median compare to the standard deviation. If the standard deviation is higher, the data is more spread out. If it's lower, the data is more compacted, okay? Their mean and the median, if their data is indicating a lower score, it doesn't mean that the class did more, it did worse. You have to look at all of the data, okay, to make a judgment call of which class did better. Okay, so that's it for this video. There you go.